Welcome to EDU World Space.
So this question is a bit of a long one, so we'll go part by part. So the first part asks for the coordinates of points A and B. So we're going to have to find the tangent slope. So it shows here on point A that it has a 9% grade, and we can see that they have a line drawn that goes through the origin. So this means we don't have to worry about a y-intercept. And when it says 9% grade, it's essentially giving us the slope, which would be 0.09. Now the hill is going in the downhill direction, so we know that the slope is negative. So the tangent slope would be negative 0.09, and since this is on respect to x, it's just negative 0.09x. To find the coordinate at point A, we can see on the diagram that it is 500 feet out, so 500 feet is our x value. So we simply plug in negative 500 for point A since we're to the left of the y-axis, and when you plug that in, you'll get that y sub A equals 45. We do a similar thing for point B. It's a 6% grade, and then going in the positive direction, so you get 0.06x, and then we have to plug in 500 again, as shown on the diagram. It's 500 feet out, so we get y sub B equals 30. Next part is a little bit more tricky. We have to find the quadratic formula for this function. So I'm going to make a new page. And so they give us the generic form of the quadratic function, which is y equals ax squared plus bx plus c. We can solve for a, b, and c by first finding the derivative of this to sort of simplify the function a little. So y prime equals 2ax plus b. So we simply plug in values for x and y based off of the two equations we found from coordinates A and B. So for point A, we can plug in the values we found, and we'll get that 2a times negative 500 plus b equals negative 0.09. And I'm going to simplify this a little bit. You'll get negative 1,000 a plus b plus 0.09 equals 0. Next, we have to find an equation for point B, since we have two unknowns right now, so we need two equations to be able to solve for them. So for point B, we do the same thing. We plug in 500 for x and 0.06 for y prime, and I'm just going to write down the rearranged form as we did with point A. So we would get 1,000 a plus b minus 0.06, and that all equals 0. Now to solve for this equation, we can simply add the two equations we found together. So this plus this, we'll just add them, because you can see the negative 1,000a and 1,000a will cancel out. So when we add them, we'll get 2b plus 0.03 equals 0. And then if you solve for b, you get b equals negative 0.05, 0.015. Next, we can solve for a by plugging b into either the first equation we found or the second. You should get the same result. So when you do that, you'll get a equals 0.0000075. So we found 2 of the 3 points that we want. Since we still need to find the c for the main quadratic function. So in order to do that, we're going to plug in everything we know into the first equation. So for a, we'll put the 0.000075. For b, we'll put the negative 0.015. And then for x and y, you can choose one of the 2 points we calculated. So if you used point A, you would substitute 45 for y and negative 500 for x. And when you plug that all in, you'll just have the plus c as the unknown. So when you solve it out, you'll get that c equals 18.25. And now we have all 3 variables that we wanted, or the 3 unknowns that we wanted, and we get a final answer of y equals 0.0000075 x squared plus, or actually minus 0.015x plus 18.25. And that's the final quadratic equation right here. The third part to this question is constructing a table. Give you a list of values that you're supposed to find the value of, that you're supposed to find the y value for. So I will just write that out here. You have negative 500, negative 400, negative 300, negative 200, negative 100, 0. Then we got 100, 200, 300, 400, and 500. So to find the y values, you simply plug it into the equation we found. So for negative 500, you get 44.5, negative 436.25, negative 300, you get 29.5, negative 200, you get negative 24.25, negative 100, you get 20.5, 0, you get 18.25, for 100, you get 17.5, and then starting from 2, we see the opposite, see it go back in the opposite direction. So at 2, we get 18.25 again. 3, we get 20.5. 4, we get 24.25. And 5, for 500, we get 29.5. So on the side I've written 1, 2, 3, 4, and 5. Those are just short for 100, 200, 300, 400, and 500. For the final part, we have to find the smallest value of the function to see where the lowest point of this bridge is. So for that, we can simply use the derivative we found earlier, y prime equals 2ax plus b. And we simply have to set this equal to 0. since a quadratic function always exists since it's continuous. And then we simply solve for x. You'll get x equals negative b over 2a. And if you plug in the a and b we found earlier, you'll get that x equals 100. So this is where the lowest point of the bridge is, and then you can see it's not at the origin, which is where the two hills met. And you can also see that this is supported by our table, since at 100 we have the lowest value in our table. So you can see right here.